Are we plugging this number for this minus the mean squared? Okay.
So guys, the quick way to do this in the calculator, so you can do L3 is L1 times L2. So there's those, right? And then L4 would be, you could either do L1 squared times L2, that would be x squared p of x. Where's your x's? L1. Where's your p of x's? L2. So you could do L1 squared times L2, completely fine. Or you could do L1 times L3, because that would be x times xp of x is still x squared p of x. So if you do L1, got it. L1 times, L1 squared times L2, you get those numbers. If you do L1 times L3, you get the same numbers. It's crazy, right? Because mathematically they're the same thing. Now, let me show you something. Let me see if you guys get this. So everybody, we've seen the sum thing, right? You go to second stat to get the list.
Yes.
And then you go to math to do sum. It's kind of a long-ass process to get there. Let me see if you guys can handle this. If I get out of here, do stat, calc. If you don't want to do this, it's fine. You can do the sum thing. A lot of you guys did. Let me show you. If I do two variable stats, why? Because I want to get the sum of L3 and L4. I need both sums, don't I? So if I do two var stats on L3 and L4, get out of there, blah. Calculate, then all this shit is shit except for the sum. That's all I want. Sum of L3 is 47.17. So it assumed L3 was the x variables, and then when L4 is the whole of the column, so guess what it's going to call? It's going to call it y's, because that's the other variable. And aren't those the numbers you guys got? Sum of x, 47.17. 47.17, and where'd it go? 2563.37. Now, please, dear God, there's nothing amazing about that, right? Both of those, the one var stats has a sum piece, so of course that's another way to get the sum. If you at least can train your brain to not care about any of the other numbers. All the other numbers don't mean anything. You just care about the sum piece, right? Or don't do that, just do the sum. All right, how are we doing so far? Is that the same numbers? I think it's the same numbers I saw most of you guys getting. Yes?
I rounded and got like the same thing, but it was like 2561 instead of 2560.
Ooh, don't round.
Don't round?
Yeah. And now this one had, you guys done, but remember there's a whole other side with a worked out problem, but also just what has to be true about probabilities. All of them have to add to be 1. Now, if they add to be 0.999, does that mean it's invalid? No, it means that there was rounding that happened, right? Just to make it fit into a chart that a human would want to look at, right? No. So, close to 1 is okay. It should be 1, but close to 1. It's 0.999. I'm not going to just go, I can't do it. It's not true, right? But these do add up to be 1. So the sum of the probabilities has to be 1, and every probability has to be between 0 and 1. I love it. So any probability just sitting around in the universe, it better be between 0 and 1, or it doesn't make any sense. Universe we know of. For some reason, I always get somebody that can't quite read this correctly, but what's the probability that some kid thinks they'll retire at age 40? 25%. Okay, good. So what's the probability that somebody thinks they'll retire, they'll be at least 25 when they retire? You could do that one of two ways. You could add all these up, because that's at least 25. Or you could do 1 minus the only thing I left off, and that's a little bit faster, right? That's related to that at least 1 is 1 minus none. So this would be 1 minus 0.07 is 0.93. like it. Several hoping they'll be Mark Zuckerberg, I guess. Alright, so I know that some of today's lecture dealt with why things work the way they do. And I told you at the beginning, I warned you, that we're going to be talking about why things work, not the way you're going to do it. Right? And yes, I do these crazy things because that's my freaking job, is to explain why do they work the way they do. Not just to tell you buttons to press or whatever. But I want you to have some connection to what the numbers mean, where they're coming from. I can see the idea we talked about before. Any standard deviation, I have to be able to see this idea in it before somebody messes with it and makes it something else. I got to be able to see this idea because that's the central idea of a standard deviation. It's the distance between the data points and the mean. So that's why I do that crazy thing. I'm trying to make sure you understand how things come together and why they mean what they mean. But now that we've suffered through Jeff's lecture, we can just do the formula. So sum up the xp of x's and we get that 47.17. The biggest mistake people make with the variance is to forget the poor little square dude here. But just remember, everything's squared still, right? This is still squared, this is still squared, I haven't taken a square root yet. Whatever gets it in your brain, that's got to be squared. So this should be 2563.37 minus 47.17 squared.
338.6.
Yeah, 338.161. So what is this?
3611.
It's the variance?
Yeah.
Look again. What is this? Variance. So how do I get the standard deviation?
Square root is
Square root that thing. I get 18.389, it looks like.
wait, I didn't get that. Wait, it's 3611 at the end. Not 1611.
Oh, I put a 17 there. My bad. So then square root that 18.395.
Yeah.
I like it. All right, now I will show you a way to check your work. Somebody help me out. Which column contains the data? And I'll tell you right now, that is a trick question. Which column contains the data? No, I mean, this column doesn't contain the data. It contains me doing shit to the data. Where is the data?
L1, L2.
L1 and L2. Kick ass. But is there more than one variable? Is there more than one question that I kept track of? Is there? What did I ask people? How old they be when they retire? That's one variable, right? One question, one variable. So now I'm going to show you something. You don't have to know how to do this, but if you want to check your work, you want to do the ultimate shortcut, right? Try not to be too cynical. I was about to say that's what most students want, but I'm not going to take this as an answer. But watch this. So if you do stat, 1 var stats. Remember good old 1 var stats. But you got to tell it, oh yeah, my data is in L1 and L2. L2 is my frequency list, how frequently that number showed up. That's why I call it a freq list. Right? Frequency list. It's in L1 and L2. Now watch, this is interesting. Look what n is. 1. Why does that make sense? Because that actually sums up the probabilities. N is 1. X bar, 47.17. Check. Sigma x, 18.394. Check. Do you see what I'm saying? And right here is where I normally have at least one student, if not 20, going, why the hell did we just do this shit in the first place? Yeah. Then you people need to be here. I'm sorry. Because just getting the freaking numbers from pushing buttons don't mean shit. You got to know where they come from, why they mean what they mean. There are teachers that do this, and this is all they do. They need to stop. Just get another job. Because you take those people, and then you take me, and then you're like, Jeff's an asshole. No, Jeff is teaching. So, yes, this is beautiful. You can check your work here. Please do. And if n was 1.2 or something, that's telling you, oh, you put some probabilities in wrong. Ain't no way it's 1.2. It's 120%. Holy crap. Yeah.
On the TI 83, is there very specific way you're supposed to do it.
Oh. So if you have the old RAM going, you just put 1 var stats L1 comma L2.
Oh.
That's why there's a comma above the 7. When you first see this, you're like, why is there punctuation on my calculator? That's why. Let's finish this up. What time we got? Ooh, keeping you so late compared to what I normally do. So this should seem very familiar. The only difference is if I catch all the people that said they were going to be 40, what percentage of the data did I catch? 25%. So I can't just add these up and divide by 6. That doesn't make any sense. I have to, so in the middle goes 47.17. If I add 18.395, I get
65.56.
65 point blah blah blah. And if I subtract 18.395, I get
28.775.
28.7 blah blah blah. So what do I catch? I catch all the 40s, I catch all the 60s, and the 65s, right?
Yep.
So what percentage of the data did I catch?
50.
40s, 60s, 65s. I can't do 3 divided by 6 because that's saying that they're all equally weighted. What percentage did I catch? 25 plus 16 plus 29? 70%. It's a little bit different than the question we had before because I don't see all the data. I see how much of these there are. So if I catch all of the 40s, I caught 25% already. But I also caught the 60s and the 65s. I add their percentages in too. And finally, how many kids believe they were retired before age 60? What percentage believe they were retired before age 60?
53%.
Yeah, 53%. 53% of 200 kids, because there were 200 kids I surveyed. And that, of course, is, like I said, 106. Holy shit. All right, that was a lot. We just did 4-1 and 4-2, everybody.
Wow.
Yeah, 4-1 is that. 4-2 adds in standard deviation stuff. Yeah.
I like this stuff.
All right. So not everybody hates it. So good.
Honestly, I hate putting it in the
Yeah.
no, like the calculator is just kind of like.
You have trust machines.
No,
I'm never gonna say it.
so you did computers are taking over.
Taking over the world before you did. Getting some of those questions, I'm like, oh, I obviously just read the wrong thing.
Oh, yeah. Thank you. Oh, so let's see. So L1 and L2 are not equally dimension. Dimension means that one is longer than the other one. There's extra data. You just have to clear it out before you. Here's where you have to delete. I don't know how long it is. But that's what, when you say dim mismatch, one of them is longer than the other one, so it's freaking out. Yeah. Sure.